Hey everyone, it's Mikki here. You're listening to Wikipedia, and this week on the podcast, I speak to Associate Professor Vicki Vieira-Potter about sex differences in adipose tissue. Super excited to bring this one to you guys. We explore some of the surprising challenges and breakthroughs in research on adipose tissue and estrogen, particularly post-menopause. We delve into the role of exercise in mitigating the metabolic risks associated with menopause and how certain compounds like ERB ligands and beta-3 adrenergic receptor agonists might mimic the effects of exercise at a molecular level. And if you don't understand that, do not worry. Vicki goes into awesome detail to help translate it into language that we can understand. We also discuss the impact of dietary choices, like things such as a soy phytoestrogen-rich diet, and also almonds actually, on obesity, with some other research that Vicki is involved in addition to how sleep restriction can influence our metabolism and glucose response. So a lot of really great information here that I think you guys are really going to love. So Dr. Vicki Vieira-Potter is an associate professor in the Department of Nutrition and Exercise Physiology at the University of Missouri, Columbia, MU. Her laboratory studies how estrogen loss affects energy metabolism and focuses on brain and adipose tissue-specific mechanisms. She and her team have demonstrated that aerobic fitness and exercise are protective against metabolic complications associated with menopause, and they use a variety of animal models and biomolecular techniques to address these research questions. And we discuss some really interesting stuff actually that she's got in the mix that she hasn't been able to publish on yet, but we chat a little bit about those things. She directs the Rodent Metabolic Phenotyping Core at MU, and she also directs the Rodent Metabolic Phenotyping Core at MU. Dr. Vieira-Potter holds an undergraduate degree from Wheaton College and graduate degrees from the University of New Hampshire and the University of Illinois at Urbana Champaign, respectively. She's also completed postdoctoral training at Tufts, where she focused on obesity and metabolism. She has over 70 peer-reviewed publications in the area of adipose tissue and cardiometabolic disease. I have put a link to Dr. Vicki's publication page and her bio that is associated with her laboratory. Just before we crack into it though, I would like to remind you that the best way to support this podcast is to hit the subscribe button on your favourite podcast listening platform. This increases the visibility of Wikipedia in amongst literally thousands of other podcasts that are out there. So more people get the opportunity to learn from guests that I have on this show, like Dr. Vicki Vieira-Potter. All right team, enjoy the conversation. Vicki, thank you so much for taking the time to speak with me this morning, your morning. This is an area which is super fascinating, but also like quite technical. So I imagine that our conversation, whilst we will keep it sort of higher level so people sort of understand the practicalities of your research, I know I do have some questions around some of the more technical aspects, which I'm hoping that we can address as well. But thanks so much for being here.
Absolutely. Thank you for having me. This is a lot of fun.
So can we talk by you just giving us some insight into your background in terms of your research and sort of what specifically led to your focus on the interaction with sex hormones, exercise, adipose tissue, just things like that?
Sure. So I've always been fascinated about physiology. And so I've got a bachelor's degree in biology and a minor in chemistry. And then I went on to do my master's degree in nutrition at the University of New Hampshire. And the reason is that I really got fascinated about nutrition and how exercise and nutrition affect the body. Again, I was just kind of fascinated by physiology. In high school, I was a runner. And so I kind of saw what that, how that affected my body. I suffered, as many young women do, the athlete's triad when you're running a lot and you stop getting your menstrual period. And that was sort of eye-opening to me. So it's sort of like, wow, this is really powerful stuff, right? Like how much we weigh and what we're doing to our body and what we eat. all that it is affecting physiology. So anyway, went on to get my master's degree. When I did my master's degree, the University of New Hampshire, I was able to kind of come on to this really neat clinical study that was going on to look at the relationship between asthma development and obesity in women. And what was really neat about that relationship that was sort of discovered at the time was that there was this strong link between obesity and asthma, but it was only seen in women. And so that's really where I began to sort of see the connections between sex hormones and fat tissue and metabolism. And that sort of was like sort of the starting point. And then, of course, it was shortly after that time where this whole idea that obesity and metabolic dysfunction leads to inflammation, and that's really what sets obese individuals up for type 2 diabetes and cardiovascular disease. So that was really becoming kind of prominent in the literature. And so I was already sort of studying the immune system in estrogen and in sort of inflammation in obesity. And so it was sort of like at the right time where everyone was sort of like their eyes were on this idea of inflammation and metabolic dysfunction. So finished that degree, really wanted actually at that point, Mikki, I really wanted to do my degree in public health. I wanted to do a PhD in public health because at the same time that I was sort of learning this stuff, I was seeing around me that we had this obesity epidemic and that the diseases that were killing the most people and affecting the most people were these diseases that are sort of preventable origin, right, with diet and exercise. And so I was really fascinated by that. And I just really saw the power of obesity and these lifestyle things in terms of being, really predictors of these diseases. And so wanted to do public health. But then sort of, I just loved the science too much to kind of move away from really wanting to know what was going on. And so made the decision to actually go to the University of Illinois to study nutrition, but with an exercise immunologist. Actually, he was studying so it's kind of blending exercise and nutrition at that point in the immune system. He was studying at the time how exercise improves immune function in elderly folks. And so I came into the lab and say, hey, do you have any interest in obesity? I'm really interested in this whole link between obesity and inflammation. Might exercise decrease inflammation in these older folks? And he said, sure, come and do your PhD and figure that out. And so that's exactly what I did. I tried to help figure that out. And in so doing, I got, again, really interested in kind of mechanisms and what is going on there. And so went to the animal model, and that's when I started doing some rodent research and looked at exercise and inflammation. And I mean, I could go on, but that's sort of how I started. And then I ended up going on and doing my postdoc at Tufts University in Boston with a person who was an adipocyte biologist, Andy Greenberg. And he had just had this discovery that when you remove ovaries from mice, they develop adipose tissue inflammation. And so I called and said, okay, I just saw this paper that you guys published in this area. Can I come to your lab and really, study like what is going on there, how ovarian hormones are affecting adipose tissue and what exercise might be doing? And so did that and then started my lab here at the University of Missouri, where we call ourselves the Fit Fat Lab. And everything I do centers around figuring out how estrogen and exercise affect fat cells and how that helps, resolves systemic metabolic dysfunction.
That is such a journey, Vicki, and it's super interesting that your sort of initial desire for public health, that's really quite different from the technical stuff that you do in the laboratory or initially you did with the rodents and then sort of working at that individual level. But that, I think, obviously the type of research you do is so critical to understanding how some of those interventions that we might put in place, right, in populations, how they actually work or whether or not they work at that cellular level. So that's super interesting. You had an article that looked at the adipocyte metabolism and adipocyte fat cell, right? That's what I'm talking about?
Yep.
Yep. In health after menopause. And you talked about exercise or the idea that exercise might alleviate some of those negative implications of a loss of estrogen. And I'd really love to understand more, I guess, physical activity, menopause, and that whole sort of that whole area there, both from a behavioural but also from that sort of mechanistic angle that you looked at as well, and just what those links are and how exercise can help alleviate sort of what occurs naturally during menopause. was that a really long-winded way of asking
Yeah, but
me?
no, it gets at the essence of what we're talking about. Actually,
Yes.
100%. And I know
Okay.
you've done some interviews with other researchers that are kind of in this space. So I know that you are aware of, sort of the metabolic dysfunction that follows menopause, and in particular, the visceral fat, kind of the belly fat, the spare tire that women develop after menopause. Or during the menopause transition, even perimenopause, and that sort of increases metabolic risk in postmenopausal women. I should say, and I know others have said this on your podcast, but in case listeners haven't seen those other episodes, but go back and see them listen to them because they're really great. And I can't remember but maybe you can put it in the show notes. Anyway,
I will.
So a couple of things. So with menopause, yes, there is this really profound increase in metabolic risk. And what's really interesting is prior to menopause, women are protected. And we see this in clinical populations as well as in the rodent populations and in other species. So estrogen is really protective. There's other things that are, contributing to this sex difference as well. But estrogen is really protective. And so women are protected against inflammation, insulin resistance in particular, cardiovascular disease, diabetes. But after menopause, that risk switches and women develop an increased risk. It even supersedes age-matched men who are even matched for obesity. So that's really interesting in and of itself. And of course, we know that exercise is the number one way to mitigate all things metabolic dysfunction, attenuate, weight gain, improve insulin sensitivity, all the things, right? So we know that. I'm not preaching to the choir by saying that, well, we just need to exercise more and then we can alleviate all this metabolic dysfunction. I wish that were true. And I think that is partially true, meaning exercise is going to be a great way to mitigate the metabolic dysfunction that happens with menopause. And many women that are going through menopause will report that their symptoms are better if they exercise. All the things get better, right? But the other piece of this is, again, I started to observe this when I was a postdoc and continue to observe it. And now it's quite well known and documented that estrogen, at least in the rodent model and other animal models, it's not as clear in humans because humans are more complicated and difficult to understand, but it looks that estrogen loss actually causes rodents to be less active. So there is something physiological, neurological going on in the brain with estrogen loss that makes us less active, or at least the rodents. And some of this has been shown in humans as well, that there's a reduction in physical activity with aging, and in particular following hormone loss. And so I think there's even been studies to show that, like hysterectomy in things like that, and in being on sort of aromatase inhibitors and things also attenuate physical activity levels. And so I can look for those papers, but the point is that there's a link between estrogen in the brain and physical activity. So there's two things going on. Yeah, physical activity can mitigate, and then estrogen loss actually reduces activity levels.
So, what is that, Vicki? Because obviously we are physically active through numerous sort of ways. There's that structured activity that we plan to, go out for our runs at 6 a.m. in the morning or go to the gym or whatever. So there's that structured activity. But then, of course, a large component of the activity we do is that non-exercise activity and that incidental activity. Do we have a sense of where this reduction in activity is coming from? Is it what people talk about with that sort of, women of this age are squeezed between aging parents and caring for children, or do we just get lazy?
Ooh, that's a fabulous question, right? And so I think these are really difficult questions to answer. And I don't think there are clear answers in terms of why this is happening. And there's a multitude of factors, right, that are going on there. And if I can even kind of nerd out and go on the preclinical side, we're trying to tease out in animals whether or not this change in physical activity behavior has to do with motivation, right? So we've become really interested in the nucleus accumbens brain region. And it turns out that exercise has all of these effects on dopamine at the level of dopamine synthesis and transmission and receptor expression, and all sorts of things are affected by estrogen. And I'm not going to pretend to understand all of how estrogen and dopamine are related because it is so complicated. But I do think it's fascinating, and I do think that estrogen is doing something in the space of dopamine, which is the motivating neurotransmitter, right? And so we think something is going on there. But I think there are also, because physical activity is such a critical behavioral aspect to our survival as a species, I think there are so many pathways that are driving physical activity, both kind of voluntary and involuntary. And think of things like Parkinson's disease when dopamine levels are lacking, and there's like this like sort of involuntary movement that happens. The movement and dopamine are so related, and so we think that's part of it, both at the motivation side and at sort of maybe the like non-cognitive side, if you will. And then there's, the other things, so I think you were sort of alluding to is like this idea that there are some people that have a lot of NEAT, this non-exercise associated thermogenesis, which is like tapping your foot or kind of being fidgety. Some people are just genetically more fidgety than others, and those individuals tend to have higher energy expenditure, tend to be leaner. Might those things happen with menopause and with aging? I don't know. I honestly don't know if those studies have been done. I don't remember seeing any studies that have sort of looked at that, but I think that would be a really interesting question to answer.
Yeah, totally. So if I'm hearing you correctly, and I don't expect you to have all the answers, but it's just super interesting to have the conversation. So we're thinking, because exercise helps with dopamine, and exercise helps us feel more motivated. Estrogen might lower dopamine, so we feel less motivated. We're less likely to exercise. So it's almost like the cycle, this potential cycle. Then we're even less likely. So did I sort of get that right, Vicki?
Yeah, no, exactly. Yeah. Yes, and it's so complicated. And again, I don't really understand what's going on in terms of the dopamine estrogen relationship as it relates to physical activity, and certainly exercise increases dopamine. We know that, increases mood, decreases depression, all of those things, which, by the way, change in menopause. So I think for so many reasons, exercise is so critical. And so you might, suggest that even if women don't really want to exercise, maybe just kind of forcing yourself, do something that you really enjoy, whether it be dancing. I think one of your previous guests was a dancer and talking about that. Whether it be dancing or running or walking or swimming or being outside hiking, do the thing, even though you're like, I kind of don't feel like doing it. And why don't I feel like doing it? Because I used to want to do it. And why don't I want to do it? So maybe once you do it, you need that little jolt of dopamine to sort of,
keep you going.
Get that wheel going, right?
Yeah, 100%.
That's a good hypothesis. In fact, I just conducted a tiny study, which isn't published. It's a very small pilot study, but it's called the Hurdle Study. And it stands for Health Enhancement via Restoration of Dopamine Following Estrogen Loss.
Oh, nice one. Like it.
And so the central hypothesis is if you can sort of restore what's going on in the brain, like if you can restore dopamine levels, if you can address kind of the mood changes that happen in menopause, can we both improve physical activity behaviors? Are women going to be kind of more likely to be more active? And two, does this trickle down to improved metabolism? So just by doing one thing, right? And so this is kind of globally like what I've been interested in my whole career, is just like how these things all link together and what's the seed that we can really address to have the biggest impact. And for me, that's the brain and behavior, because again, going back to my roots and being really interested in public health, I've always been really drawn to this idea that, gosh, we know diet and exercise are so critical. If we could put it in a pill, it would be like,
oh yeah,
the best pill out there, right? But most people don't do it. Why is that? So that's kind of been the core of my question. Like, why is that? So with that study, we want to address that. And I have some lofty goals for that study, and I hope to kind of continue in the future. But the first step was we had women do this like very short-term strength training intervention. And it was just a way to get women together to kind of increase that dopamine, social interactions. I don't think the strength training on its own would have any substantial effect on the things we were looking at, but we just kind of wanted to see if they increased their activity levels in doing that. And they did a little bit. And so that was cool. And of course, we looked at all kind of neurocognitive markers via surveys and things like that. And it's too early to say, if there's anything there. But I'm really sort of interested in this idea that let's address those brain changes and see what happens metabolically, physically, all of that.
Yeah. Do we know whether, and hey, we may not know this and you may not know this, which is totally fine, but does taking estrogen as a menopause hormone therapy, does that increase dopamine and thus increase exercise? If the loss of estrogen?
Fantastic question. And I'm so glad that the conversation is sort of now broadening in the space of hormone replacement therapy, because as you know, it was sort of a taboo subject for so many years. And I think so many decades of women have kind of suffered because just clinicians aren't prescribing it, and there's just so much kind of negativity around, and it was like sort of some misinformation or maybe just some misunderstanding of some data, whatever the case may be. And so I'm glad that conversation is kind of coming to light now, but I don't know that those studies have been done. I would love to see those studies to see what happens with hormone replacement therapy in terms of I do know cognitive variable. I think there have been studies to show that cognitive function, memory, those sorts of things are really improved with hormone therapy, and in some women, particularly women who start early and don't have other risk factors, and of course all of those caveats. But I do think there's some data to suggest that that is true. That exercise, that hormone replacement therapy or hormone therapy can improve cognitive health. To see if that would trickle down to improved physical activity, I would love to do that study. In fact, that's a fantastic idea.
Yeah, well, you write that down on that whiteboard behind you, Vicki.
Yes.
That can be the next thing. Yeah. So if I go back to your paper then, which is a little bit geeky, but I'm super interested in it. So obviously we know that the loss of estrogen affects metabolism, affects physical activity levels, but does it also affect, as I understand it, the fat tissue itself and the fat cell itself? Like, what's that relationship?
Yes, it totally does, which I think, again, is fascinating, right? So estrogen signals through its two main receptors. There's two isoforms or two forms of the estrogen receptor, alpha and beta, and they are prevalent on almost all cells in the body. I mean, it's just so amazing to me, astonishing how many tissues and cells in the body are affected by estrogen, in males and females. Certainly estrogen is the major reproductive hormone in females, but present in both sexes and affects metabolism in many ways and affects many tissues, including adipose tissue. Those estrogen receptors are expressed on adipose tissue, and the feminizing receptor, the estrogen receptor alpha, we call it the feminizing receptor because that's the receptor that mediates kind of the reproductive effects of estrogen. It's also the receptor that kind of mediates the negative effects of estrogen on breast cancer growth and that sort of thing. But estrogen receptors are both present on adipocytes, and females tend to have more estrogen receptor alpha. And estrogen receptor alpha has been shown to mediate many protective effects of estrogen, namely those effects on insulin sensitivity, lowering inflammation, and maybe even improving mitochondrial health. So I'll geek out for a second and just kind of go to that adipocyte health, because that's really what I've been studying for the past several years, is really focusing on the adipocyte. And I always like to explain adipocyte health as a triad. We think of the adipocyte as just being like sort of an inert cell, just storing lipid and not doing much good for us except storing extra energy, when that's not really at all true. It's doing so many metabolic things. But when I describe adipocyte health, I like to talk about this triad of inflammation being sort of a negative, right? Inflammation goes up with excess adipose tissue storage, adipocyte hypertrophy, obesity. Inflammation tends to go up because there's a stress response in the cell. That tends to be bad. It kind of causes insulin resistance, and it decreases adipocyte function, if you will. We then have insulin sensitivity. Insulin sensitivity is great for the adipocyte because it allows the adipocyte to store lipid, which we think, we don't really want the adipocyte to store too much lipid because that's obesity. But the adipocyte, the adipose tissue, is so critical for responding to insulin, storing lipid, and taking up glucose. And so it's a glucose clearing organ, and it's responsive to insulin. And those are good. That's part of the reason, I think, why females are so protected prior to menopause, is they're very insulin sensitive, and we're very good at storing fat in a safe way because we don't want excess lipids circulating around and excess glucose circulating around. So these are really critical to the adipocyte. And the third of my triad is mitochondrial function. And this is the aspect of adipocyte health that's probably received the least amount of attention, but it's kind of becoming more popular discussion in the adipose tissue world, mostly because we've discovered, probably like a couple of decades ago now, that that brown fat is a fat that is healthy. And we don't have a whole lot of this fat. We used to think that we only had this fat when we were newborns and we sort of lose it all when we're adults. We now know with new technology and PET scanning that, humans do retain some of this brown fat. And it seems that the more you have, the better off you are metabolically.
Yes.
And what's different about brown fat and white fat is that the brown fat is chock full of mitochondria. That's really what makes that fat healthy. It doesn't store fat. Its job is to burn fat, which is kind of counterintuitive because it's fat, but it burns fat to produce heat.
Yes.
And this is prevalent in all mammals. It's a really important temperature regulating tissue, but it also, in creating that heat, it's burning some energy. So individuals that have more brown fat are burning more energy. And so back to the white adipocyte, that sort of turned our attention to the mitochondria, because we don't think of mitochondria as being in fat cells, really. We think of them as being in muscle cells and in brain cells and, so important. But they're also important in fat cells. Although we don't have a lot of them, they're very important in the cell health. And the more we have, the better. And it turns out that exercise is a way we can upregulate mitochondria and fat cells and improve fat cell health. And there are other kind of drugs and things that can maybe do that. And so to kind of bring that full circle, that triad of the adipocyte health being inflammation, insulin resistance, and mitochondrial function, once you kind of affect one of those three things adversely, the other two often follow suit. But when you can improve one of those, the other two often follow suit, right? So they're very intimately connected. And what's great about exercise is something that kind of tackles all of those things. And in my work, I've noticed lots of parallels between what exercise does and what estrogen does in terms of adipocyte health.
Oh, amazing. I've got a few follow-up questions on that, Vicki. Some of them, they're all related, but they might be tangents as well. So feel free to go, don't even think about that. But firstly, you mentioned the fat cell sort of hypertrophy, so it gets bigger and that leads to dysfunction. Does it not just multiply, or do we not just get more? So I can't recall that term actually off the top of my head. But hyperplasia. Yeah, does that also occur? And is that an issue?
So it's sort of, the data are mixed on that. It used to be thought that when you can differentiate adipocytes rather than filling them all up, make more small adipocytes versus filling up the ones we have, the former is healthier, right? So more little fat cells is better metabolically than big fat cells. And that is true. I think there's lots of research to support that a bigger adipocyte is less insulin sensitive than a tiny little adipocyte. And having more adipocytes is better. So you'd be better off multiplying them than growing them. It looks like both happen. And it used to be thought that, well, if you do adipocyte hyperplasia versus, filling up those adipocytes, that's going to be better metabolically. And I think that is still the case, but now I've seen some literature showing that that's not always the case. In fact, in some obese individuals, there is a lot of hyperplasia going on that isn't protective.
Yeah.
So
okay.
It's hard to have a hard, fast answer on that. I think probably both occur. But what's interesting kind of about that is one of the anti-diabetic drug classes, the thiazolidinediones, one in particular is rosiglitazone. That drug has been prescribed for diabetes for many years, and it's very effective. And one of the ways in which it works is it causes adipocyte differentiation. And so it's actually triggering adipocyte proliferation, and it's making more of these small little insulin sensitive adipocytes. And that's part of the mechanism by which those drugs work. But as you might guess, a side effect of those drugs is weight gain.
Gaining weight. Yeah, for sure.
It's interesting to illustrate the point that the smaller the adipocyte, the more insulin sensitive.
Yeah. I get that, because I've understood for a while that that fat tissue in itself is a good buffer for that high energy state that you mentioned, with high fatty acids in the bloodstream and high glucose in the bloodstream. We need to buffer ourselves from that metabolic environment, because over time that's, leads to oxidative damage and stress in the cell. So that makes sense to me, actually, that would improve that the overall health outcomes. And I can't let you talk about brown fat without asking about your opinion on cold water thermogenesis and techniques like that have been, ice baths and stuff have become increasingly popular as a biohack, if you like, for metabolism and that brown fat generation. So what is your take then, Vicki, on whether or not or how effective they are? Like, do we have a sense of that?
Yeah, it's a fabulous question. I think, so if you were to do those studies, and I think those studies have been done in rodents who don't have a say in the matter of, are you too cold? Or is this really uncomfortable for you? You could do cold exposure and create a lean mouse, even if you were feeding that mouse a high-fat diet. I mean, I'm guessing that those studies have been done. And so that's not a question. We do know that cold induces brown fat. That is the number one stimulus. It's central nervous system driven, increases thermogenesis and brown fat, and maybe even some white fat. We can talk about kind of white fat browning, but I think that is true. And in terms of an energy expenditure increase, as you know, long term, you just need a little bit of an increase in energy expenditure to have really a substantial impact long term, because these things are cumulative. But in terms of weight loss and facilitating fat loss, can cold exposure help? Sure. I think that's true because it increases energy expenditure, right? Providing the individual isn't going to compensate for those calories later in the day. And the individual is okay with this, is cool with this, right?
Yeah.
Right? I am someone who would not be okay with that. Like, I am very uncomfortable being cold. I would much rather run than sit in the cold, right?
Yeah.
But, to answer your question, I do think it stimulates brown fat. And I do think there's a metabolic boon to doing that.
Yeah. And do you think that this then could play a role in some of the protective mechanisms that we're talking about with the mitochondria content of fat tissue and the negative impact that removing estrogen has? Like, is there any sort of link there that we can then go and go, hey, perimenopause, menopausal women, maybe some cold water therapy would help you? Or no, it's a leap too far.
Yeah, no, I love it. I love it. It's such a beautiful question. Of course, it's a question that is like near to my heart and we're trying to work on and figure out because it's very complicated. But to answer your question, yes, right? Like, estrogen affects fat cells. Estrogen affects fat mitochondria. In menopause, we lose estrogen. So mitochondria are adversely affected. And cold is a way to increase certainly the mitochondrial density, probably the mitochondrial quality, although I don't really know that those studies have been done. The other really important thing about estrogen is it is sort of one of these, I don't know if if it would be considered an adaptogen. I'd have to ask Andrew Huberman about that, right? I'm sure he's done podcasts on this, but if it's really considered an adaptogen. But it's something that kind of buffers oxidative stress. It allows the cell to upregulate mechanisms that deal better with oxidative stress, right?
Yeah.
So that we know. And so I think we become less resilient as we age, and exercise is definitely something that can increase resilience, right? Can it completely replace that effect of estrogen? I don't know. It can't hurt, but does it completely rescue any deficits? Probably not. But what we're really becoming interested in is, what is the synergism between estrogen and exercise?
Yes.
And so can exercise, or can specific estrogen mimetics, or maybe, they're referred to as SERMs, these sort of estrogen-like compounds that are not estrogen, but have some of the same effects of estrogen, can we improve the mitochondria in such a way that they're more responsive to exercise? That is a question that I love, and I'm really trying to figure out how to sort of address that question, because I think it's really translatable. I think this whole idea that it becomes more difficult to lose fat as we age is real. And I think that is something that women struggle with, and probably, men too, with aging. It's just their, changes in hormones and various changes in aging just make, fat loss is just more difficult for a variety of reasons. But can exercise sort of an estrogen specific compound synergize to improve fat cell responsiveness and, kind of facilitate lipolysis and fat loss? That's something that I'm very interested in kind of delving further into. We had an interesting finding in the lab preclinically, where we showed that exercise actually upregulated an estrogen receptor on fat cells. And it was the estrogen receptor beta. So it wasn't the estrogen receptor that really has been shown to mediate many metabolic effects, beneficial effects of estrogen. Alpha has really received most of the attention in terms of the receptor that mediates, as I mentioned earlier, the metabolic benefits of exercise. Much less attention has been given to ER beta, but my lab has been very interested in ER beta and other labs as well. In fact, over the past decade or so, more and more studies are showing that estrogen receptor mediates protective effects, particularly in the adipose tissue. And so what we found was that exercise increased ER beta expression, estrogen receptor beta expression in adipose tissue. And combined with the studies that are also showing that estrogen receptor beta specific ligands, so drugs that activate specifically that receptor while not activating as much the other estrogen receptor, improve fat cell metabolism, improve mitochondrial biogenesis and browning of adipose tissue, and in so doing, improve metabolism and reduce weight gain. So because of that, we're really interested in this idea that there might be synergism between using an estrogen receptor specific agonist, estrogen receptor beta specific agonist, and exercise to improve mitochondrial health of adipocytes and improve fat loss. So that's something that we're hoping to figure out. We're working on that.
So, Vicki, with regards to those SERMs that you mentioned, the things that can work synergistically with exercise, are you referring to your work on phytoestrogens in different foods, or were they supplements? Like, can you talk to us about what these particularly are, and are these things even available for, not that, I mean, I'm not suggesting that people now go out and do all the things that we're talking about, but, you know, just to put it in those practical terms for people to understand. So what are we talking about?
Yeah, no, it's a fabulous question. And it's such a confusing topic when you start getting into this idea of SERMs and things that look like estrogen in the food supply, in the environment, and maybe in, the pharmacological space, although there's much less in the pharmacological space of these SERMs other than those agents that are used for treating breast cancer and, reproductive things. So there's space there, but, there are all of these estrogen-like compounds everywhere. And people are very, understandably so concerned about this because we don't want things that look like estrogen interfering with the real estrogen in our body. And so that's kind of scary. So there's like a lot of kind of controversy over this, right? And so you mentioned the soy stuff. So when I first got to Mizzou and started my lab as a nutritionist studying estrogen and fat cells, of course, I was interested in soy. And, there's all of this kind of research showing that plant-based diets are really healthy and they're pro-longevity and they have all these metabolic benefits. And in animals, when you feed them a soy-based diet, they don't gain as much weight as when you feed animals like a corn-based diet or a diet lacking soy. And so, in fact, one of the reasons that I sort of became interested in this is when I was doing diet-induced obesity studies, and I was hearing from people, well, just make sure that you have a phytoestrogen-free diet because the animals won't gain as much weight if you don't get rid of the phytoestrogens. So I'm like, oh my gosh, why, right? Is that the case? And so we did studies early on where we fed rats a diet high in phytoestrogens. We actually fed them kind of a soy-based diet, but we had the manufacturer enrich that soy with the phytoestrogen. So those compounds, they're phytoestrogens, which means plant estrogens. They look like estrogen. They bind to estrogen receptors with like thousands-fold less affinity than estrogen. So they're extremely weak estrogens, but they do bind to estrogen receptors. So again, there's controversy there because of that. But on the metabolic side, we showed huge improvements in those animals. So we showed that their insulin resistance was improved. They didn't gain as much weight. They had all of these gut microbiota changes that were really positive, all of these benefits. And so we then started to really wanted to we wanted to study those phytoestrogens and figure out what they were doing and get at mechanisms and all of that. But unfortunately, we couldn't get any money from NIH to do any of that work. And I think it's because it's just too messy and it's too complicated and people are sort of, so I'm hoping, and maybe I didn't try hard enough. I tried for some years and then I'm like, okay, this isn't working. I got to kind of move on to something else. But I do kind of want to get back there because I do think it's important. And I do think soy is a really great power food. I mean, it's this plant protein that's complete, and these phytoestrogens look like they might have some benefit. You ask where people can find, you can get phytoestrogens. For a while, when I was super excited about the soy phytoestrogen business, I started taking the soy phytoestrogens myself because I was struggling. Again, research is me search, right? So I was at the time struggling with amenorrhea, like I often do with stress, being an assistant professor at the time and very stressed and having young kids and all the things and running. I again stopped getting into. I'm like, why am I, and so I'm like, well, maybe I'll start taking these phytoestrogens and see if that has any, at least it's maybe protecting my bone a little bit. Turns out it's not like estrogen. It's so, the affinity is so much less than estrogen. It really is not a replacement for estrogen. But the important thing is, my personal opinion on it after a solid read of the literature, I think, is that there's really no downside. I mean, there have not been studies to show that people that consume more soy have more breast cancer. In fact, it's the opposite. Studies have shown that, women that are taking phytoestrogen supplements or just have a high soy content of their diet, their bones are not statistically stronger, like, in terms of statistical significance. But when I get into the data and look at the data, it's a small increase, but it's never significant. It's one of those, but the point is, it's definitely not having a negative effect. And those studies, by the way, were in postmenopausal women. I think in premenopausal women, it's different. We've got naturally circulating estrogen. So those are going to take precedence on those receptors over, the small amount of phytoestrogen circulating around. But in postmenopausal women, where estrogen levels are really low, maybe there is a space for those phytoestrogens. And it doesn't seem to be negative. I don't think it's a replacement for hormone therapy. I think if a woman is a good candidate for it, and her doctor is kind of on board with, her risk profile, and she's, wanting to do hormone therapy, I think I would do hormone therapy myself over just, I'm going to, consume more soy. But in addition, I think it's fine. I think those plant estrogens are healthy. I don't think they're feminizing on males. There's not been any data to show that. And so, yeah, overall, I think the kind of the fear of soy, I think, is overblown. Personally, in society in general, I do think there's an allergenicity of soy, and that's really has to do with how we manufacture, how we grow soy, and it's it happens. One of those GMO, and I think it's more that's the issue with soy that I think is but the phytoestrogen story, I think those may actually have a benefit,
and as I understood it as well is exactly the what you described, that it may have a beneficial effect. There don't appear to be the downsides that was all that you would see on social media 10-15 years ago, that soy was dangerous or anything like that. So it was interesting then that you saw these results in your preclinical trial, but unfortunately you weren't able to run the human study. Is the same true for almonds? Did I read that right? Was almonds another one?
That's a completely separate separate thing, but it's still, it's adipose tissue, right? And so again, it's kind of under this umbrella of what we eat and what we do affects the fat tissue. And almonds are interesting because they're just one of these sort of superfoods that have all of these vitamins and minerals that are protective and antioxidants and healthy fats, which are beneficial as well. And they're high in fiber. And from kind of a weight loss standpoint, lots of studies have shown that if you consume more almonds and other nuts, it has a positive effect on weight status, meaning it's helped weight control. Used to be thought that stay away from nuts. I know in the 90s, I was just like, oh, I would never eat a nut. Nuts have too much fat. We had such bad information back then. Luckily, we've, grown as a scientific community in that space, and we now know more. But anyway, but it looks like nuts are a really healthy food, and so no one has really looked at how almonds in particular affect fat cells. So that's what we're doing.
Interesting.
Women almonds for 6 weeks and doing fat biopsies before and after, and we'll see how almonds affect their fat tissue. Too early to tell what's going on there, but again,
an interesting question.
Yeah, thanks.
Yeah, nice one, Vicki. Now, if I go back to the exercise the fat cell and the two different receptors for estrogen, you mentioned what the functions were of the alpha estrogen receptors, but they didn't have the same role or the beta receptors didn't do the same things. Like, do we know what the beta cell or the beta receptors actually do, or is that still in that unknown?
Ooh, so excellent question. So we know lots about ER beta in the space of, say, cancer. There's been lots of work sort of with prostate cancer and other types of cancer. It looks like it actually has a positive, a protective effect in some cancers. And in terms of, though, the question you ask, in terms of like metabolism, we know much less about ER beta than we know of ER alpha. And here's why. In the early studies that were done, where we were trying to identify which of these estrogen receptors was mediating the metabolic effects of menopause or hormone loss, of course, animal studies were conducted where you either knock out one receptor or the other, and you see what happens, right? And so in those studies, it was very clear very quickly that the estrogen receptor beta knockout mouse was pretty boring, a model, meaning you wipe out that estrogen receptor beta and the mouse is pretty normal. Not a whole lot happens. What's that? Didn't do much. Whereas if you knock out ER alpha, that mouse quickly becomes fat. And it doesn't matter male or female. There's an adipose tissue, a negative adipose tissue phenotype. The adipose tissue becomes inflamed and insulin resistant. The mouse gains weight, becomes systemically insulin resistant. All of the things. We've done studies in older mice where we sort of replicate that finding and we show that, yeah, when you take an ER alpha mouse, an ER alpha null mouse, and overectomize that mouse, remove the ovaries, remove ovarian estrogen production, nothing happens because we've already shown that that mouse is very metabolically dysfunctional, and it's because of the loss of ER alpha. And so nothing really happens. But in those studies, we found something really interesting with because we also did those studies in ER beta null mice. And what we found in those mice is that those mice had those mice that we overectomized had an adverse reaction to overectomy more than the wild type. I mean, it was subtle, but it was like they responded worse to hormone loss. So we think that there's something going on that is dependent upon menopause state or state of ovarian hormones that is dictating how these estrogen receptors may be mediating some metabolic benefits. And so we're really interested in ER beta as a potential target now. And by the way, that's been shown by others too, that when you overectomize those ER beta knockout mice, they gain more weight. And when you take those estrogen receptor beta knockout mice and feed them a high fat diet, they gain more weight as well.
Oh, interesting.
So yeah, so it seems like when you challenge that mouse, there's something going on. It's more subtle than with ER alpha. But the reason we're so excited about it is that, again, the effects of ER beta seem positive in terms of sort of the global effects. If you are going to sort of take a drug or a serum that's going to activate that receptor, the risk profile would be quite low because we don't really know any negatives associated with estrogen receptor beta signaling. In fact, it's to be protective against breast cancer and other cancers. So because of that, we're quite interested in what we can do with ER beta in the fat cell, particularly in the setting of estrogen loss. So those are things we're kind of working out. And then back to my story about the mitochondria and fat cells, this is where things get very interesting because so estrogen receptors are present on adipocytes and they're also present in the mitochondria. So this is wild and fascinating, I think, both estrogen receptors. But it looks like there's even a greater localization of ER beta on the mitochondria than ER alpha. So ER beta in particular, we think is doing something really important in the mitochondria. And of course, my focused on the adipocyte, and that might be true in other types of cells as well. But I'm really thinking in the adipocyte, we need to do the studies to really substantiate that. But that's sort of the hypothesis that there's something going on with ER beta in the mitochondria. And I think it's acting as protective, and it's kind of protecting the mitochondria from producing excess reactive oxygen species and perhaps even buffering some of that. This is all sort of hand waving. So we don't have hard data to support that. This is just sort of hypothetical based on kind of the literature as it currently stands. But it's an exciting idea, I think, that we really want to explore more and then kind of move into the space of, well, what can we do with this, right? Are there drugs that activate that receptor that might be able to improve adipocyte metabolism and certainly, respond with exercise? And those are unanswered questions at this point, but exciting.
I totally agree. And because I was just thinking, what are the practical take homes from this discussion for people? And obviously mitochondria is super important in anything which would enhance mitochondrial function. Or maybe, what about, Vicki, there's a lot of talk about fasted training, increasing mitochondrial biogenesis. Like, is there a space for that to help improve, I don't know, menopausal outcomes or, is there anything there that you can talk on, or is it that actually just not really a question that's been asked or not even that interesting?
Well, I don't think it's not interesting. I think it's very interesting. I think sort of the blanket statement I would make is that mitochondria are the most critical cellular organelle in the body, right? I think, if you think about the mitochondria, they're the only cellular organelle that when they stop functioning, we die, right? Like, think about that, right? It's like, they are really critical, and they actually evolved on their own. They evolved like another cell, and then a cell engulfed them and they became part of us. And that's sort of how we became to be, a species, right? And that's, I think, really, really fascinating. So the mitochondria, couldn't say enough about how important the mitochondria are and how mitochondrial health really dictate metabolic health and systemic metabolic function, from the brain to the heart to the fat to the muscle, pretty much everywhere. And unfortunately, mitochondria quality, function decline as we age. And so anything that we can do to improve mitochondria is going to be beneficial. I'm not sure if fasting improves mitochondrial function, because that's not really my area, but I think probably studies have shown that, because again, it comes back to, I think, the commonalities between fasting and cold and exercise, and trying to think what else we do that's sort of like counterintuitive, that like, this is stressful. Why are we doing this? Right. But it's hormesis, right? It's when you induce a stress, when you put a stress on the body's forced to react and respond. And the mitochondria are really, I think, the organelle that does that sort of hormetic response. In fact, even mitohormesis is a thing. It's a term, meaning the mitochondria become more resilient. And if the mitochondria become more resilient, we're going to be in a better space overall. And again, that's in the brain and the fat, everywhere. And so I think if intermittent fasting is a way to do that, I'm all for it. If cold exposure, and if someone is in loving the cold exposure, I know there's all this talk about, I take a cold shower every day. I did it once. I'm like, yeah, I'm good. maybe someday I'll like, but it's too much for me. But no, I mean, whatever you can do, for me, it's exercise. I mean, I would so much rather, go for a run than, pretty much anything else.
No, I get it.
Eat my cake and then run too. So running and exercise in general is really what does it for me. But I think kind of that there's the commonality, the common thread is that we're stressing the system. We're forcing the system to become resilient. And anything you can do to force the system to become more resilient, I think is going to have a benefit long term.
I agree. And I think, there's a lot of talk in social media or in my space, which is that, women are overstressed, and too much stress leads to more negative outcomes attached to perimenopause and menopause, etc. But I speak to women who are seriously scared to do anything other than walk because of the stress response that their body might endure. And I'm like, that's just not the way that the body works. So there's almost been, I feel like there needs to be more of a message of what you're talking about with building resiliency and becoming more adaptive and responsive to what's sort of going on, rather than shielding and protecting yourself from anything stressful, which might just make a dysfunctional system even more dysfunctional.
Oh, yeah, that's so wise. Yeah, I completely agree. And so sort of like, and so people might be sort of resistant to things like HIIT training, because we hear about this very stressful, and you might say, no, I'm already feeling very stressed. My body is older and it's stressed. I'm not going to do HIIT training because that's going to be way too much stress on my body and it's going to maybe increase injury risk. Probably true. But that step from 0 to 1 is just as critical. So if someone doesn't walk and decides, well, I'm not going to do HIIT training, but I want to go out and go for like a very, low intensity walk every day. That's amazing. That 0 to 1 is a huge jump, right? Like just doing something is so beneficial. And so, yeah, I mean, I get it. And I wouldn't advise someone who is just not feeling their body is ready for, this kind of stress stimulus, whether it be a nice cold shower or HIIT training or whatever the case may be. That's, that isn't essential to building resilience. I do think, though, that you're absolutely right on in that we are all so stressed and becoming more so, right? As just society goes on and technology evolves and just our lives are becoming busier and our demands are becoming greater. And just this stress has really become a part of our life that we've sort of like just taken as like, this is part of what we do in life. And I think finally the message is becoming like, no, this is really bad for us. And so we need to be taking care of not completely shielding ourselves from all stress, because some stress is good, but sleep and doing things like yoga and mindfulness-based meditation, if that's your thing, all of the things that we can do to kind of put stress reduction, I think in the front, I think is in front of like sort of the priority list and making sure that that's a part of my life, right? I'm going to do all these things that I need to get done, but I'm going to make sure that I have space for whatever it is that's going to ease my mental stress burden, right? And so both things I think are really important.
Completely. But I'm with you on, exercise. I mean, one, exercise is a great stress relief if you are fit and that's what you do it for. A couple of final questions for here. I hope it's all right. One is, we're talking about exercise and people were probably wondering, what kind of exercise are you talking about, Vicki? Like, what is the exercise that I should be doing that is going to have these effects that you're studying?
Great question. Well, sort of like back to kind of what I alluded to, which is any exercise is better than no exercise. So if someone is not doing anything, just walk. Do whatever, dance with your grandkids or your kids or, whatever it is outside. I mean, I'm a big advocate of outside. I think there's also lots of research about natural sunlight and being in nature and all of that are really great for stress relief and have all of these things. We don't even know what they're doing to us, but they're doing all these beneficial things. So I think any exercise is better than no exercise. I think as we age, strength training is so critical. I mean, we can't, stress that enough because, our bone density goes down as we age, and strength training is really a way to, we lose mass, we lose muscle mass. It's just part of, the mitochondria deteriorating and we're losing our lean mass as we age. So I think anything we can do weight bearing, if you're not someone who likes to lift weights at the gym, wearing a weight vest, I think is great. Any weights you can do, yoga, Pilates, those things are great. It's much weight bearing though. If upping that a little bit, I think would be advised for everyone. And just start where you are. I mean, if you're someone who's been super active their whole life, it's just like maybe like for me, I'm always like, okay, how can I tweak my routine? I've sort of ignored the strength training piece for most. Like, okay, I really need to up that game, right? Like, I'm in this phase now. It's like I am mid-40s. Yes, I'm there. So, like, okay, need to start changing things up. So it depends where you are in life, I think. But strength training, walking is great. Cardiovascular, strength 2 training. There is some research on HIIT and how like this high intensity interval training is really effective at, building resilience and fat loss and all of those things, and even stress reduction. I will say actually one more tiny thing. This is not published data. So, with hand waving or huge caveat. But one thing I did notice in that little study I did with the postmenopausal women is we looked at kind of correlations between things that were improving in these women. And one thing we found, and we looked at physical activity in all the domains. We looked at very high, vigorous physical activity and then moderate. And we found that the vigorous physical activity in particular associated very strongly with an improved in perceived stress.
Oh,
so
nice.
Perceived stress index. So that type of exercise in particular in that group of women, and I think there's other research to support that, had a role in seemed like stress reduction. So I think all exercise, there's not a bad, every exercise I think has its benefits, and just to
Yeah.
tailor it to the individual.
No, I love that, Vicki, because again, some of the strong messaging out there is that you absolutely have to get into a gym, you have to do deadlifts, squats, you have to do heavy lifting as the only way that you should be training sort of in perimenopause and menopause. And that's such a scary message for women who have never been into a gym and who are just don't feel safe in that environment. So that sort of start where you're at, because anything is a load. And so I think that's a really helpful thing for people to hear. And hopefully this isn't going to be I don't think it's going to be a complicated question, but you mentioned visceral fat well early on in our conversation. And obviously that belly fat is something that a lot of women struggle with as they hit perimenopause and beyond. So any specific, or is there anything in addition that you can talk to about that type of fat in particular, or is everything we've discussed going to be beneficial in terms of that fat reduction?
Yeah, I think yes. To answer that last question, I think all the beneficial things, exercise really does target visceral fat. And that's another great thing about exercise. And visceral fat is something that we gain in menopause. It's just, it's physiology. It's the change in estrogen and how it interacts with its receptors. And we become more male-like, get that android fat as you know, we go through menopause. And that's something that really does happen. Exercise is a great way to attenuate that, particularly that type 2 training and more kind of aerobic training, anything that's going to really stimulate lipolysis. So low to moderate, physical activity, but any physical activity. I think even studies have shown strength training can reduce visceral fat. Pretty much anything you do, I think, in the physical activity realm is going to be beneficial in some way. I forget the other question that you asked, but
and is there anything particular about mitochondria and visceral fat or lack thereof, or any sort of dysfunction that you're interested in looking at particularly, or is that not yet known or not really just irrelevant?
Yeah, that's a really great question. So we're beginning to understand more about depot differences. So meaning like, how does visceral fat differ from subcutaneous fat? In general, the subcutaneous fat is healthier than the visceral fat. And all of the things that I mentioned earlier, the triad of adipocyte health, those all apply, right, to visceral versus subcutaneous. And so I think because the visceral fat has that profile that's just not as healthy, it tends to be more lipolytic. It tends to just not as insulin sensitive, and all of those things create this sort of poor metabolic profile. In particular, another thing that kind of happens with obesity and with menopause and with weight gain is the accumulation of fat in the liver. And the belly fat, the visceral fat, is really a large contributing factor to excess liver fat. And so that's another reason why that belly fat is adverse, and why we want to kind of keep that at bay and with exercise. And that's a great way to do that. And sort of like, and so the health profile of subcutaneous and visceral really does reflect that. Something we've been interested in looking at in like our preclinical models are differences in those depots and then comparing sexes. And so it's a little early to tell. We did publish one paper, I think in Cells, showing those depot differences. In particular, we were interested to see if female fat was more prone to browning. And what we found kind of interestingly was that in females, the visceral fat was actually more prone to browning. And males, the subcutaneous fat browned kind of equally in both sexes, but in females that had sufficient estrogen, that visceral fat was more sensitive to browning. So it seems like maybe estrogen is doing something protective to that fat in terms of allowing it to respond to some of these treatments more so. And so how can we keep that response as we age? That's kind of the question that we're trying to figure out.
And that's where all of the stuff we've talked about with exercise and with the potential, if you really want to, cold water therapy. But that's just a sort of a lot of hand waving around that stuff. But that's where all of these things that we're talking about could be beneficial for someone in perimenopause and menopause.
Absolutely.
Yeah.
Absolutely.
Amazing, Vicki. Well, thank you so much for your time. This has been a great conversation. It's been a bit geeky but I love a geeky conversation. And I know that my listeners also do. Like, some of them just really appreciate sort of doing a deeper dive into the mechanisms, because, I mean, the message, you're not saying anything that people don't already know about, hey, we should all be exercising and our metabolic health is important, but understanding the mechanisms and I think those sex differences, I think is super helpful, because I think we both are really lucky that we've we've probably been forever athletes, and because I'm a runner as well, and it is just what we do. It's sort of how we're wired. But I know that's not the case for everyone. So the more people understand the reasons why, potentially the easier it is for them to jump on board. I don't know.
Yeah,
and you made it so easy. You gave them a lot of options.
Yeah, well, thank you. This has been a real pleasure. And one thing I will leave you with, in that I never forget this conversation I had with a woman, like early on when I was sort of starting out, and she asked what I did for work, and I told her, and she said she was, in menopause, and she said, I just joined this group called WOW, Women on Weights, and she said she was someone who hadn't exercised her whole entire life, and just discovered exercise in menopause because everybody was saying you need to exercise, and she joined this group. And she's like, I wish someone told me earlier in life that exercise is fun. She said, I never knew it was fun. And she said, I love it so much. She's like, even if it made you fat, I would still do it. I just love that. So I'm
yes.
that like public service, like even if you think you don't love it, if you think you can't try it, and there's going to be something that works for you.
Oh, 100%. No, I really love that, Vicki. Thank you so much. Obviously, I'll put links to your lab in the show notes, and some in the papers that we were discussing. Is there any other way that people can find out about your research or what you're doing?
Yeah, I mean, those would be the ways. I need to have a better social media presence. That's something I'm looking toward. And actually, really, I'm so motivated by you and others who just do such a fantastic job in this podcasting space, because, what I do in the world is like, I'm doing all this work, but it's like nobody's reading PubMed, right?
Yes.
Like, and that's where I am, right? I'm in PubMed papers. And so I'm really passionate about getting, this really useful information out to people. So I so appreciate what you're doing. And I would love to enter this space. And that's kind of on my 5-year plan. Like, I want to start a podcast.
Brilliant.
It's going to be a bit different. You do great work in this space. And I'm trying to figure out what is a niche that I can take in that space. But anyway, in the future, maybe you'll see me on a podcast. The podcast will be called Discover Me. And
amazing.
Really it's going to be geared toward graduate students, and it's going to be sort of a way to encourage graduate students who are struggling to keep going. And it's going to highlight, prominent scientists and how they've failed in life. So that's kind of my, it's going to be
amazing.
Like acknowledging that this is hard, right? And we all fail, and we just keep going, even if we don't have grants, and even if we don't get funded, and our research is, getting rejected from journals, we still keep going because we're passionate. And anyway, that's hopefully.
That sounds fabulous. It sounds to me like you absolutely have your niche down pat. Actually, you've got
to actually do it.
Yes, I think so. You need to get some of your grad students onto it. Actually, you need to get people helping you out in that piece. Vicki, thank you so much. I hope you enjoy the rest of your day, and I will. And people are just going to love this conversation. It was brilliant.
Well, thank you so much. It was really a pleasure. And you enjoy your evening.
Thank you. Alrighty, hopefully you enjoyed that as much as I enjoyed chatting to Vicki, and that you learned a little bit more on the really geeky science stuff. But I think that you'll agree that she did a great job of sort of breaking that down for us. Next week on the podcast, I have the pleasure of chatting to Beth McKenzie, who is a former elite pro triathlete. She is the co-founder of Wheaton Republic, and she's an amazing runner, having recently come second at Tarawera Ultra in 2024 in the 102 kilometre event, which was actually 104 kilometres. And she very recently took out the win at Ultra Trail Australia by UTMB. So I'm super stoked to be able to chat to her all about her transition from triathlete to ultra runner, and of course how she balances life, business, fun and training. So that is next week. Until then though, you can catch me, Mikki, over on Instagram, Threads and Twitter at Mikki Williden. on Facebook at Mikki Williden Nutrition, or head to my website, mikkiwilliden.com, book a one-on-one call with me. All right, team, you have the best week. See you later.